Hi there. This is the explanation videos for how to actually go about taking the training. In the previous video, it was just an introduction to the course, but this is actually how the course is structured and how to interact with it. So all of the assets for this course are open source and are being held in the Secure Innovation glibc heap exploitation training repo. In here, there are various folders. The resources folder is really important. This has VM installation steps, various tools that I made for this, and then how to use with a remote setup. And there are instructions on how to do that as well. Now, most important things in here, though, are in the modules. So every module you're going to be doing is broken up into one of these folders. Each one of these folders has the same assets. First, it's going to have a PowerPoint. And this PowerPoint is all the slides that I'm going to be talking about in here. Again, everything's completely open source now. And within here, we're going to have exercises and challenges. Each exercise also has the same thing. It's going to have a challenge file. So this is going to be a C-based challenge that you're going to need to solve. It's going to have a compiled version of it. And most importantly, it has a compiled version that has the LD patched in it, because you need to use specific versions of libc for specific challenges. Otherwise, you start running into weird issues. Next, we have the solution and start files. The start.py is a Pwn Tools template for every challenge. When I was initially teaching this course, it was completely unreasonable to expect people to write the entire Pwn Tools file from scratch. So some of these are effectively just fill in the blanks. And although this sounds a little bit annoying, I'm not here to teach you how to use Pwn Tools. You should know that. Or you can figure that out by reading documentation or whatever else. My job is to teach you heap exploitation, and I really want to focus on that. By doing these fill in the blank type things, you can see this to do here, it makes you really understand what's going on. And you don't have to worry about little misunderstandings with Pwn Tools. I want you to understand the core concepts of heap exploitation, and that's all I want to focus on. If it was a general binary exploitation course, it would be different. But this is very specific to the heap, so I just want you to get that. So if the start.py is just a template, then the solution is what actually has the challenge. Now here, this is the first exercise, but it's not too hard anyway. And there's no to do anymore because we filled it in. So that's how that works. Now, in order to actually run these exercises, there are two different ways to go about doing this. When I first made the course, I made this on an x86 MacBook, but shortly after that, the M1 became popularized. This course I built on x86. You theoretically probably could port it to ARM and it would be fine, but that's not what we're doing here. So there is a virtual machine that is linked below, and there are installation steps within these files here that you can use in order to figure that out as well. However, I have an M1 now, and I no longer work my old job, so I actually don't have that MacBook, and my older Windows computer couldn't run the VM and use OBS at the same time. So I'm going to be doing something different. While I was building this course, I noticed that more and more people were running M1s, and so I set it up for them to have a remote setup. And this remote setup allows you to run it in a Docker container. And although you need to run this on a computer that isn't ARM, so you need an x86 computer to run this on, you can run this on a Linux server if you want. The problem with this, though, is you have to edit stuff in Vim and you have to use tmux, so it's a little bit harder to use, so I'd recommend using the VirtualBox setup regardless, but I still thought it was worth calling this out because this is what I'm going to be using for the course, and it does work pretty well. So I'm going to show you how to use this. So there is a file called, if you're in the remote setup and resources directory, that's where you want to be when you're done. But there is a thing called setup Docker, and I didn't want to put a big zip file that has everything in it. And so if you run setup Docker, it will, which I'm not going to do because I don't want to rezip stuff because it takes a second. But if you run that script, it will zip everything into a zip file, and then it will copy that into a Docker container when we actually run it. So if you go to resources, remote setup, we use start Docker container, and I do Maxwell 3. This will start a Docker container that has all of the information that we need for it. So you can see here we have the House of Heap exploitation. Now if we go into modules, like we talked about before, intro to malloc and exercise 1, we can see a good amount of stuff happening here. So we have, like I said before, the source file for fixed chunk, the start.py and solution.py, and then if you do LA, you can see the fixed chunk, which has a particular version of libc. If you remember from looking here beforehand, there is a libc versions repo. And this has a bunch of different versions of libc that I custom compiled for this course with debugging symbols in order to make this easier. So if we do start.py, it's going to crash. Why is it going to crash, I wonder? It crashes because it can't find the terminal to use. This makes perfect sense because we need tmux for this. It's trying to open a terminal that it can't find. All of the start.py files are going to start the binary, but then it's going to attach to them in GDB. This is really nice because we have one screen for interacting, another screen for debugging. I'm not very good with tmux. I know how to switch between screens. I know how to look at output. That's about it. And I'll show you how to do that. So now if we do start.py, there are two different screens. We have GDB running here, and then we have the interactive terminal here. If you do Control B, arrow up, it will go here. If you do Control B, arrow down, it goes down. And then if you Control B, left bracket, you can scroll up to see more things. That's literally all I know how to do in tmux, and it is let me do this course totally fine. So that should be enough, but you can look up how to do more things with tmux online. So we're going to do continue to see how this goes. Continue again, and you notice that this crashes because we have an invalid pointer. And if we look at the start.py file, this makes perfect sense. We're editing the size of this, and the size is set to 0. That's an invalid size. You try it for an invalid size, poof, whole thing blows up. That makes perfect sense. You'll notice here that we have GDB and init files that are specific to this. This is because every challenge has pre-made breakpoints for you that are set up in order to make it easier to debug. Of course, you can remove these, turn them off, do whatever you want. If you fix chunk.c, we can also see what's happening here. And there are a couple other things you can do that I think are kind of fun. If you go to one of the challenges that has multiple steps, for instance, if we go to FD Poison and challenge 1, you'll notice that there's a versions file. This versions allows you to do this in steps. So maybe you're stuck on one step, like finding the vulnerability or find the information leak, but you don't want to just skip to look at the entire solution. I got you. I think it's the grab. Yeah, so the grab command will allow you to go between different steps. So if we look at the help, we can do grab show, and this will show you the different setups for this. So we can do a mangled version, a fast bin version for the solution, or you can do the different stages. So I can do grab version 1. Grab stage 1. And now we have a stage1.py. And this is really cool because we can now start from this point. Or if you want to do grab start, this will go back to the original, or you can do grab start mangle. Maybe do start mangle. Okay, well, there's a way to do that. I don't remember off the top of my head, but you can get different starting points and to make the challenge harder. Point of mangling is a protection that was added to glibc malloc 2.32. So if you want to try to solve this challenge with pointer mangling turned on, that's how you want to do it. So to recap, this is where all the assets are going to be at. In resources, remote setup is how you can do all the GDB or all of the Dockerized stuff. Within each module, we're going to have helpful information. We're going to have challenges and exercises and a PowerPoint that's going to be used for that. And then we're going to have these various files to make it easier for you to go about solving with as well. What else? Am I missing anything? Oh, I think how I'm going to structure these videos is I'm going to have an explanation of the technique itself, which is going to be the first part of the PowerPoint presentation. And then I'm going to have a separate video for the introduction to the exercise. And then a separate video for the solution. And if there's any other quirks or things I want to talk about, I will probably make a separate video for that. For instance, on the write, what, where primitive section, I'll probably talk about Tcache stashing as a separate video, just to separate the different techniques. Cool. Well, with that, you should be good to go in order to start the course. Start with the first video, which should be Intro to malloc. Thanks for watching.